I'm very pleased to be here. It's my first time in Odessa. I've been to Istanbul, I've been to Warsaw, Czech Republic, Hungary. Never been to Ukraine before, so it's my first time. And I'm very pleased. Now, one of the organizers was asking me if I have time to see the city and the beach and things. I said, unfortunately, no. But I will come next time with my wife. Okay, so that's something for the future. Saturday is kind of unusual to have a conference. So today, my wife and I would be doing housework at home. She has to do it alone today, so it's something for her, okay? So a little bit about me. So I hope you'll be able to see that okay. Let's see. Okay, screen's a little bit fuzzy, but hopefully it'll look good. Okay, so as the question was asked, I'm an old guy, okay? So look, gray hair, white hair, no hair. I mean, this is what you'll look like when you get to my age, okay? Is this really what you want? Think about it. So my first job when I started in IT, I worked for Reuters in London. Fabulous company, awesome. I worked with some of the smartest people I've ever worked for in any IT organization. These guys, PhD holders, they're really, really brilliant, very, very bright guys. But first 8 months of my life there was the worst 8 months ever, okay? Because they got me working on these old systems, PDP-11s, switches, 8-inch floppy disks. Who remembers floppy disks? Anyone? Okay, great. Some of you remember them. These things were 8 inches, right? Terrible, and I hated it. But at the end of 8 months, the first 8 months, I understood why they made me work on these old systems. Because these old systems have business value. Someone has to love them. Someone has to care for them, okay? And that's the way it is in IT, Not everyone gets the chance to work with the latest and greatest, okay? You let other people do that. They take the risk, okay? So the guys next door doing data science, okay, let them do data science, okay? Wait a few years. When things are settled, you guys, you'll be able to take advantage of some of the capabilities. You will offer them the tools and the technologies to be able to do their work better. That's the key thing. And as you can see there, I've done lots of things. So been there, done that, got the T-shirt kind of thing. The other company that I would draw your attention to is Infomix, okay? So it's on the right-hand side. So it was a database company. And I had the great privilege when I worked for Infomix, I worked for Mike Stonebreaker. And if you know anything about database systems, you will know who Mike Stonebreaker is, okay? He's a legend. Mike is the guy who invented Ingress, Postgres, Vertica, SciDB, VaultDB, okay? List goes on. Awesome guy. A couple of years ago, he won the ACM Turing Award, and that is like the Nobel Prize, okay, in computing, okay? Fabulous gentleman. A couple of years later, I got into big data, so I worked for Hortonworks, worked for DataStax, then I was an independent consultant for a few years, and then last year, GridGame approached me. They're based in Foster City, okay, although it's a worldwide company, and they have developers in Russia, I think many parts of Europe as well. And they said, well, we have a job. We're looking for someone to help us evangelize Apache Ignite. And I said, I don't know, never heard of Apache Ignite. But if you want someone who can help develop communities, who can write blog posts, who can build demos, I can do it. So they offered me the job. So I have the best job in the world. So they pay me money to talk about open source, right? I'm not here to sell you anything. It's all 100% free. Everything you see today, it's all open source. It's all free, okay? I mean, how cool is that? So there we go. Again, I've worked in lots of different areas, variety of development languages. Long time ago, it was C++ and C, more latterly Java and a few other things like that, and lots of presentations and publications as well. Over the years, I've been very fortunate to work on some publishing projects. Don't buy any of these, okay? Look at the titles. Object-oriented databases. Who uses them? Nobody. XML databases. Who uses them? Nobody. What's the cool thing today? Hot thing today, anyone? NoSQL, maybe? MongoDB, right? 10 years, they'll be gone as well, okay? So that's the nature of technology. New things come along, people use them for a while, they solve business problems, then they go, new technology replaces it. That's life, okay? That's what happens. If you're interested, so when I started working for GridGain, as I said, I knew nothing about GridGain, I knew nothing about in-memory data grids, never heard of Apache Ignite. So my boss, Dennis Magda, so Dennis is the PMC at Apache for the Ignite project, and he said, why don't you write? Share your experiences, so as you learn something, you write about it. So on DZone, I've been publishing since last year, and so the early articles, very basic, okay, just talking a little bit about various components of Ignite. More recently, it's got a bit more technical, so things like recovery, failure, for example, clusters, and machine learning, which is what I've been, my boss has been getting me to write about. So there's some stuff there for you to have a look at if you want to know more. Okay, so enough, and let's move on. Close this, and let's have a look. Okay, so Apache Ignite. I'll say a little bit more about that today. So the focus of today's presentation really is to look at how Ignite and Spark can work together. Okay, so Ignite does some things very well, Spark does other things very well. And the two are complementary technologies, and they can work well together to solve some types of problems. Okay? And so it's a fairly short agenda. I have a few demos to show you. Now, in English, we have a phrase, Murphy's Law. Murphy's Law says that anything that can go wrong will go wrong at the worst possible time, okay? So, live demos are live demos. Things may work or they may not work. I mean, that's the nature of technology. Fingers crossed, everything will work today, okay? So just keep hope for that. So, we'll look a little bit about how RDDs, I mean, I know this is kind of a very low-level data structure that Spark uses. And really, we are supposed to use DataFrames, but still, there are some nice uses that we can make for RDDs. We'll talk about DataFrame support as well, and then leave some time for some questions. Okay, so in kind of a couple of lines there, and I apologize, I know it may be a little bit difficult for you to read, so I'll read this for you. So what is Ignite? Ignite is a memory-centric, distributed database, caching, and processing platform for transactional, analytical, and streaming workloads, delivering in-memory speeds at petabyte scale. Quite a mouthful, okay? Architecturally, at a very high level, it looks like this, okay? So at the bottom, you can see we've got this memory-centric storage. So historically, what Ignite was an in-memory data grid, okay? And there are commercial products out there as well, such as Hazelcast, you may have heard of it, or Oracle Coherence, for example. These are two commercial examples. Subsequently, Ignite has moved on. It does a lot more, and we'll talk a few of those features and capabilities today. So one of the things that Ignite does very well is that it integrates with third-party database systems to give you two really major capabilities, scale and performance. And it can cache data. So if you're working with relational systems, transactional, Postgres, MySQL, Oracle, Ignite can work very well with these. It can take the schema, the data that you have available, and it can cache that data, okay? And if there are changes in the cache, these can be propagated back to the backend third-party store. If there are changes in the third-party store, Ignite sees the two. So the two are kept consistent. And it can work with other things as well, so HDFS, NoSQL, but because these things tend to be non-transactional, they don't typically support ACID properties. So for example, if you look at the majority of NoSQL databases, they are eventually consistent. Very different problem, okay? Have to think about that carefully. MarkLogic and MongoDB version 4 provide ACID and transactional capabilities. But the vast majority, Couchbase, Cassandra, these types of systems are not. The other thing that they provided last year, particularly, was native persistence. So now, in this distributed cluster environment, Ignite can store the data as well as just caching it. So now that you have the ability to really work with huge amounts of data. So let's say you've got a petabyte of data or 10 petabytes of data. Probably you're not going to cache all of that data unless you are Twitter or Facebook or Google, okay? I mean, but the rest of us, our needs are more conservative. So we can store that huge amount of data on disk, and we can cache a certain portion of that data in memory, where Ignite can traverse these structures at memory speeds and give you that scale and performance. These are the two things. Okay. In terms of interfaces then, if we start on the left-hand side, then it's got SQL support, and it's SQL 99, right? So you may like SQL or you may hate it. The fact of the matter is, today, SQL is intergalactic data speak, okay? It's used with BI tools. If you need good developers to work with BI tools, to work with relational systems, chances are you can find good developers who have SQL skills. Very easy to find them, okay? It's a key value store. Historically, this is where it's come from, as an in-memory data grid. So because it's cluster computing, essentially how it distributes the data, it just applies a hashing algorithm to the key, and then it knows which machine within the cluster stores that particular data. And the value can be anything, okay? It can be a simple type, character, string, integer, or it can be complex type. So it could be a financial instrument, for example, or a healthcare record, okay? It's transactional. It's more than just caching technologies. There are plenty of good caching technologies available today. You might be using Memcached, for example, or Redis. All right? These are great key value stores, great caching technologies. But Ignite does that and more. Okay? So it's transactional. It can work with ACID-based transactions, lock-based, okay, which we talked about with third-party stores, or they can be lock-free, optimistic transactions. You know, two different types. Compute services we won't cover today, streaming. So if you work with Spark streaming, for example, or you work with Flink, Ignite can act as a sink. It can take the streaming data, act as a sink, process that data for you as well, store it, do other things, whatever you want. And the last thing there is it will do machine learning as well. So they've added this machine learning library just this past year. It's gone GA now, and also as part of that, there are genetic algorithms that are supported as well. Okay? The nice thing is that this library has built from the ground up, and it works in a distributed environment. So you may be doing machine learning. Typically, you know, on a laptop, for example, you've got your train and test data. You may be able to do small amounts of machine learning capability on a small machine. But once you scale up, and then people are working with huge amounts of data today, big data, I mean, you know, this is what people talk about, data lakes. And what about data that you're streaming in? So from sensors, IoT devices, wearables, okay? These things are sending in large quantities of data. We may want to process that stream data as it arrives, okay? So we can run some SQL on it, for example. Or we can run some machine learning algorithms on it as well, okay? So these are things that we can do, and for which Ignite can really help us. Okay. So, moving on then. So why Spark and Ignite? So sometimes there's a little bit of confusion. So people kind of look at Ignite and say, okay, I'm already using Spark. Why would I want to use Ignite? Okay? So, just to dispel the confusion then, some differences between them. So, Ignite, think of it more as a kind of a database, as a sink, something that can store large quantities of data. Okay? It's a compute platform, SQL, transactions we talked about. Key value. It does collocated processing as well, okay? So very, very useful feature. So in a distributed environment, what we want to avoid is a lot of movement of data. If data naturally is associated together somehow, we store that together then, and we process that. That avoids costly movement, costly joins when we're running SQL. It can do OLAP and OLTP, okay? Spark is fabulous for streaming and compute jobs, okay? It's an awesome compute engine, really, really great. But it doesn't provide storage, okay? You have to integrate with third-party stores, other capabilities to really work with Spark effectively in that environment. And of course, it has its own machine learning as well, MLlib and other things as well. It does well. Okay, so historically, where Spark has come from is really as a replacement for a lot of these MapReduce workloads, which Hadoop was originally designed for, but for which performance was terrible because we used to use disk for storing a lot of this intermediate steps. Okay. Other thing then, so Ignite can act as a memory-centric store for Spark, okay? There is tight integration between them, all right? It can boost your DataFrame and SQL performance, and you can share state as well, okay, which is a very useful feature. All of this means that you can do analytics a lot faster now, okay, because there is less data movement between the two technologies. They are integrated and work really, really well. So graphically, we can kind of see it like this at one level, all right? So you have this notion of this kind of shared RDD or data frame structure. So Spark can see this as an RDD or a data frame, and Ignite sees it as a cache. Okay? It's just a slightly different name. So the two technologies are able to see the same data structure in a slightly different way, but they can share that same data structure and really work very effectively with it. And obviously that gives us some benefits as well, which we've kind of listed roundabout there. Okay. So what we can do then is, if we briefly look at RDDs first of all, and how we can actually deploy it, well, naturally you have a number of different ways that you can do this. You have the notion of separate sort of clusters, if you like, and separate job processing. That's one way. Okay, and then of course, if we're going to share this kind of RDD abstraction, then we have the ability to really benefit from both technologies. And you know, if you've worked with Spark, that RDDs are supposed to be immutable. The thing is that if you're now sharing this data structure and you want multiple applications to access it and process it, Ignite has to see it in a way that it's mutable, it's changeable. It needs to be, as data are changed and calculations are done, new data arrives, we need the flexibility, and therefore this data structure now has to be mutable. And of course, we can run SQL queries on top of this as well. Okay, and I'll show you an example of this, how we can do this very shortly. Okay. So the key thing is that all of the standard APIs, whatever you're working with in terms of the Spark environment, you can use those just as you've been doing so before. And you can now plug in Ignite as sort of kind of storage for this, and this really works quite well. And let me show you the first demo, okay? And first demo then, we'll focus on RDDs, okay? And then I'll show you the DataFrames one in a few minutes' time. So what I'm going to do, I'm going to set up a Spark master, okay? I'm going to have one Spark worker. Now, there's a limit to what I can show you because the laptop memory and resources are a bit limited, okay? But this is just kind of proof of concept, just to show you what's possible. What we'll have then is an application that just writes into this RDD structure. It's just a long list of numbers, 100,000 numbers or something like that. And then we have a reader that just reads that data back. And then what I'll do then is I'll kill Spark, both the master and the worker, okay? So they're gone, Spark is gone now, but this shared structure is still available, our Ignite cluster is still running, and then we can plug into that and read from another application. So my code for the RDD writer and RDD reader is written in Scala, but now I'm going to have a Java application that actually accesses that and be able to retrieve data from that. Okay, so let's switch to I'll just minimize this. Okay, so I've got a couple of windows here. Now, what I'll try and do is zoom in on each one, okay, and then just show you what I'm doing. Okay, so let's have a look. Let's go in here first of all. Hopefully you can see that quite well. All right, so this is the window where we're going to launch our Spark master. Okay, so just do this on the command line. Let's kick that off, okay? So that just takes a moment. There we go. Over here, I've got this one ready. I'm going to start one worker, okay? Just kick that off. All right, down below, in this window here, let me try and... Ignite can be launched a couple of different ways, okay? You can do it from an IDE or you can do it from the command line. I'm just going to do it from the command line here. And it's got a configuration file which it's going to pick up, and that configuration file happens to have some information about this shared RDD, okay? It's just standard, and I shall kick that off, and Ignite will launch, and we'll just have a cluster with just one node. Not much, okay, but that's all we need, okay? There we go. So that's going to take a moment or two. All right, let me just shrink this down. So we've got a couple of things working so far. All right, now I've got my application, which I'm going to run from the command line. I'll show you that in just a moment. Now, one more thing we can do is to kind of have a look at what's going on. What information can we glean in terms of our Ignite cluster? Okay, so there is this web agent that I'm going to launch. Okay, just give that a moment or two. It's picked up the fact that we have a cluster running, okay, one node just down here, okay? And I can now connect to this from a web browser. Okay, this console. Okay, so this is running on GridGain's website, console.gridgain.com. You can create a free account on here. In production environments, do not do what I'm doing, all right? You do not run this on somebody else's website. You would install this behind your firewall on your own systems, okay? Now, I work for GridGain, so for me it's okay, and this is a demo, right? But don't copy what I'm doing, all right? Very, very dangerous, right? So, what this does, it just gives us some statistics and the ability to have a look at what's going on. And if we look down here, you can see we've got this shared RDD. At the moment, you can see no activity, nothing happening. Okay, that's fine. We'll come back to this in just a moment. Okay, so let me just minimize this. All right, so let's zoom in here. Now what we'll do, okay, so as I said before, this is just using Maven. I've just written a simple Scala program, just package it up as a jar file, run it from the command line. All it does, it just creates a big list of numbers, okay, writes them into the shared RDD, and just returns when it's finished, okay? So if we just run this, just give that a moment or two. Okay. You might see one or two small messages coming out there. It's just log4j and various things that haven't been configured. Okay, so just give that, there we go. It's very helpfully tells us there's a new version as well. Okay, so we're done, right? Now, not very dramatic, but if we now switch to the web console and have a look. Okay, now, if you're sharp-eyed, you'll see this now says 100K, okay? Previously it was 0. So it's written 100,000 numbers into this cache, okay? So think of a cache as just a data structure, a bit like a relational table. You can create as many as you want, all right? And you can do joins across them as well. It's all fine. That's fine. Okay, so now we've got this big list. Why don't we read back what we've just written from here, okay? And again, a little bit of Scala here, just simply reads back this list and then does a little bit of filtering as well. And if we do this, this takes a moment or two just to give us back a result. Okay. Okay, so it's got, I think, we're running a number of processes and these are configured into a number of partitions as well. So, oh, there we go. Always be careful of Java errors. There we go. Right, there. So I think that's pretty much done. If I minimize this a little bit and then scroll up, I think we've got there. So it's worked, okay? So the filtering is just saying basically how many numbers have we got greater than 50,000? 50,000, okay? That's all it does. Simple filter. All right. Now, let's kill our Spark master, and first of all, kill the worker, go over here, and let's cleanly shut down Spark. Stop this. There we go. Give that a moment. Now, notice, of course, Spark is now gone, right? But I've still got Ignite running, okay? I've still got my cluster, one node, running. And now if I switch to an IDE, what I have here, and by the way, these are examples that come as part of the Ignite distribution, okay? So everything that's here is free, okay, downloadable, and you can work with this. And what we have here is a simple Java program that basically does pretty much what I showed you running from the command line, okay? But it's packaged up as just a Java program now. Now, what I've done here, I've commented out some of the things that we don't need. So, for example, I do not need it to create that list for me. So notice, for example, that I've commented out the lines where it actually fills the RDD structure. I don't need it, okay? It's already there. So now if we run this, okay, so give that a moment. Okay, try and zoom in a little bit. There we are. So now it's whizzing through that list. Takes a moment or two just to finish off, okay? And then at the end, it does some SQL as well, processing. So, okay, so remember, Spark is gone now. So with this data structure, we have the capability to share state amongst applications, okay? So in this case, happens to be Spark and Ignite, but once Spark is gone, we can do additional processing, okay? And then if we just look back here, there's a little bit of SQL that was run as well. It just summarizes and prints out some numbers on the table, okay? So there's some SQL running as well. So, all right, so let's go back to our slides. A couple more slides to show you, and then we'll wrap up. All right, now, RDDs, of course, are a very, very low-level structure, okay? But still very useful, I think, okay? And the world is moving towards this notion of DataFrames. So if you work with relational systems, you work with relational tables, you will understand what this is, okay? So the same thing, pretty much, okay? So optimizing Spark's Catalyst engine. So Catalyst is great. You know, they've done a lot of work, and Databricks has invested a lot of time and effort really in trying to look for optimizations and ways to improve the execution of you know, these SQL-like sort of queries, and taking advantage of the knowledge that we've built up over a long time in terms of how optimizers work. So what we can now do with this capability when we're working with Ignite is in-place execution on the Ignite side. And again, no data movement, okay? That really helps a lot, improves productivity. And for most of the scenarios, I think this is going to be very, very useful. Makes the life of developers much easier, I think. So the key thing is that in terms of queries now, if we've got something like this, so we've got some SQL query that we want to run, that's okay. So we've got our initial query execution over local data, okay? Reduce multiple results in one. So on the Ignite side, for example, we can do sort of collocation of data, okay? So if we look in this particular case, what we have, this notion of cities and countries, all right? If we didn't use this capability, let's say some of these cities in Canada were located on this node where we've got data for India, and let's say some of these Indian cities were located over there, that query would still work, okay? It's just SQL. System figures out the best way to do that for you, but we would have data movement across here, which we want to reduce, okay? And this is a simple example with 2 nodes. Now imagine, say we've got 1,000 nodes, all right? And we have a lot of data movement between these nodes. That's not good. Poor design, okay? So there are some things that we can do in terms of improving this capability, and so this integration, I think, helps us. And on the Ignite side, in terms of where that data is stored, again, we get some improvements. So store data frame in Ignite. all this is documented, okay? So append, overwrite, error exist, ignore, a number of sort of capabilities that we have. And then we can read the data in very simply, just specify configuration file. And if you've looked at the documentation, let me zoom in a little bit. Okay, so this is all standard Spark stuff, okay? So if you look at the documentation that they provide on the Spark website, oops, I think it doesn't like being zoomed in. There we are, that's better. Okay. So standard stuff. All right, so let me show you a quick example then, and then just wrap up, okay? So what we have in terms of the DataFrames demo, this is an example of, say, an IoT type of application where we might have a stream of data coming in, okay? So it could be from sensors, could be from wearables, for example. And we've got a sensor data that kind of simulates that, okay? Because I've got no actual streaming data that I can connect to at this time, but what we have is something that simulates that. And then with this, Spark does some processing, Ignite connects using the data frames, and then it does some processing as well. So it's, again, applying and using these two technologies together to be able to solve a particular business problem. Okay, so, and again, Ignite, it can act as a store, it can act as a database for Spark, so this is a very useful thing. And because of the tight coupling between these two technologies, I mean, that can be really useful. All right. Now, what I need to do is, because I've got a slightly different version of Ignite, let me kill this one. Okay, that one's already done, and let me just close this project. Okay, and then open the IoT one. Here we go. Again, don't worry too much. I know the text is a little bit small to see, but let me kick off a couple of these processes again, and we'll talk through as we launch these things. All right, just give that a moment. So there we are. So what it says there, so I've launched my sensor data generator. Okay, now as you can see, it's rather underwhelming. All it just says is just it's running. All right, so essentially it's just generating some random data, writing it to a socket, and then the data going nowhere. There's nothing connecting, reading it at the moment. So not much happening. Okay, that's fine. We'll start an Ignite node as well. Okay. Just give that a moment. Okay, so that says Ignite node up and running. And we'll start our Spark streamer here as well. Lots and lots of info messages. It's just log4j hasn't been correctly configured. Okay, so as soon as we get some data that's coming up, okay, there we go. So let me try and zoom in a little bit here. All right, so essentially, if you look here closely, it's just coming out as relational data. Okay, so stream data is coming in, Spark is taking that, it's doing some processing, sending that on to Ignite. Ignite is taking that, summarizing, running SQL on that, output the result to the console. Okay, so again, combining the two technologies, and this is just loop forever. So just keep going and going until I kill it. Okay, so, and again, this example, standard data frames, shows you how these two things work effectively. There's another presentation that I have that does IoT, and we talk about a technology stack that uses this and discusses it in more detail. Unfortunately, today we just don't have time for that. All right, so let me just wrap up then. And then we finished, okay? So, where to get the examples? Ignite, Spark, IoT data frames. So, my good colleague, Val Kolichenko from GridGain, if you look on his GitHub account, He's done this, okay? And then actually, the DataFrames is a kind of a superset, okay? So there's a separate RDD example that does exactly the same thing, but using RDDs. So this is, again, simple case. And again, you guys, your developers, you'll understand, look at the code, you'll pull it apart, you'll be able to understand it. It's principally Java, okay? Some SQL statements in there as well. And in terms of the documentation then, particularly for the Spark and Ignite integration, it's all on README. Okay, and then I think I'm done. So there we go. So any questions? Any issues? Any concerns? Yes, question there.
Hello. Probably I didn't get something, but what are the reasons of using Ignite SQL while we already have Spark SQL?
Right. Okay, so the question was, why do we have Ignite SQL when we already have Spark SQL? So the key thing is that in this particular presentation, what I tried to show you was the tight integration between the two. But the thing is, Ignite doesn't need Spark, and Spark doesn't need Ignite. There are scenarios where you might be working with Ignite just by itself. It has its own SQL 99 support, which is designed to work with those cases where Ignite is working with a relational system, or you just decide you want to work with SQL by itself. The Ignite SQL and the Spark SQL, for this example, they work very well together. They are closely aligned, they are tight. You have a choice, okay? You may decide that it doesn't make sense to replicate everything in the Ignite environment. Ignite will understand Spark SQL. It will work with it directly. So I think that's what you're trying to get. Right. Okay. So the question is really about performance, and because of things like Catalyst and those kind of optimizations. Yes, you're absolutely right. But the way that this works is that, and we didn't have enough time to go into it in detail, is that Ignite can essentially, the integration prevents or gives you the ability to avoid a lot of data movement. So you're essentially running the same sort of SQL statements over the data, regardless of which environment it sits in. There's a lot more we can discuss about it, but I think because of time pressures, maybe we can take it offline. But I kind of understand what you're saying. So in a sense that you're absolutely right. I mean, and if you think about it, if you're working, say, in machine learning, Spark has a fabulous machine learning library, MLlib. Ignite also has a machine learning library, slightly different in terms of their focus. So on the Ignite side, it's very much, I think, the case that it's a technology that, again, you don't need Spark for. You can use it standalone. It works great as a key value store, as a caching technology, as integration with a relational system. It's cluster computing. But it provides persistence, which I think Spark does not. That's one of the main things. Spark is great for a lot of in-memory operations. It does execution, fabulous kind of community, streaming, machine learning type applications. Again, very good. So what I was trying to get across in terms of the message is that there can be scenarios where the two may work. You may need them to work together, and therefore avoiding a lot of data movement, avoiding a lot of replication has some benefits, particularly for developers, particularly for end results, okay? And I apologize if that didn't come across particularly clearly. It's kind of tough, Okay, great.
We have more time for questions.
Yeah.
Okay, it is great that we can use Ignite to cache data across all Spark context. But from the persistence perspective,
yes.
If, for example, I already have HDFS cluster with some kind of information based on Parquet or Auro or even CSV, can I, for example, set up Ignite to use this cache, use this as cache and check if something is updated and updated in Ignite. Not just start Spark and put something in Ignite, but already have a layer that understand what is on my HDFS and provide me only relevant information.
Okay, so the question is really asking, okay, we talked about one aspect of the the ability to share state. Are there other sort of environments that, because if we've got things like HDFS, for example, and we've got Parquet files and other things, is there some integration capability available? I think that's the essence of what you're trying to ask. Do we have the ability to work with those as well? Ignite provides an in-file replacement, if you like, for HDFS. It's a caching. Essentially, you view it as HDFS if you're an application, but it's just a cache technology. There are things that you can do, yes. If you have a specific business problem, get in touch with me offline and we can sort of discuss it in more detail, because I think without understanding your specific requirements, it's kind of hard to give you a general answer. But yes, you can. There are APIs and other things very well defined as well, and it can work with other sort of third-party stores, if you want to cache data from other sort of technologies as well. It's possible, yes, and doable. Yeah, that's great. And so I guess just to
We can ask.
One more question?
Yeah, I think we have for one more question.
One more question? Okay.
No, okay. One sec, I'm running.
Okay, this guy's going to ask a hard question, so
Hopefully, yeah, this is Jacek. I've got another talk about Spark just right after Akmal.
Yeah.
Thank you for the talk. It was kind of inspiring.
Yes.
You definitely inspired me to look into Ignite.
Yeah.
But my question is about this. How could you compare Ignite as a caching solution
Yes.
to Kafka? Is there any
Okay.
relationship? And how well Ignite would work with some use cases over Kafka and
Okay.
vice versa?
Okay.
Thank you.
Okay. Yes. So the question is really asking about Kafka. Okay. And what I would say is that I don't think Ignite competes with Kafka. Kafka is a fabulous technology. Again, Confluent, the tech company behind it, they've done a wonderful job in terms of building the awareness. It's an Apache project as well. Very active today in terms of the user and dev list. Ignite has a Kafka connector and adapter. So notice in the high-level architecture, which I showed almost at the beginning of the presentation, I mentioned streaming, and I talked about Flink and Spark streaming. But in fact, we've got connectors for lots of other technologies as well. So Ignite tries not to replicate or duplicate what these other technologies do well. So it doesn't contain a streaming engine by itself, but can work well with streaming engines. It doesn't have a queuing technology by itself, but can work with queuing technologies. It can work well with Kafka as well. So, and if you're looking for specific use cases, I think we have some customers doing this, and I'll be very happy to, pass their details on. You'll be welcome to talk to them if you would like to do so. But I think, especially with Ignite, so remember historically where it comes from is as an in-memory data grid. Last year, particularly, they expanded its capabilities considerably, so it does much more now. But again, they're keeping those capabilities manageable to the extent that there is no point in this technology doing everything possible, all right? There are lots of great technologies out there, such as queuing technologies, streaming engines, Spark itself. And so the idea is to enable Ignite to integrate well with these technologies and give you some additional capabilities which they don't provide. So Ignite, for example, can work as a distributed SQL database. So if you've heard about things like CockroachDB, for example, or Google Spanner, it can behave like that. Or you can just use it for caching, if that's all you want. But it does transactions, supports SQL, a whole bunch of other things. So I think the essence of this is that it will integrate with Kafka, it will work with Kafka, but tries not to replicate what Kafka does. No point. Those guys do a great job. Why try to simulate or emulate what they do? So it's the essence of it.
Okay, guys. So actually, I'm just saying that the guys on the track, they're a bit longer.
Okay.
So we have potentially more time if you have questions. Okay.
I guess what I was going to say, because on these slides, my contact details are not here.
Oh, okay.
So if you want to reach out, and by the way, here you'll see that we were running the sensor cache and the temperature cache. Okay, can you see these caches have been picked up now by the web console, but if you want to reach out to me, it's just first name dot last name at gridgame.com. Okay, so Akmal.Chaudhri gridgain.com. Be very careful how you spell my name, okay? I'm from South Asia, and my surname is spelled about 8 or 9 different ways, all right? That's fact of life, all right? So if you may send the email to somebody else, okay? So I don't think we've got anyone else with the same name as me working at GridGain, but by all means, feel free to .com.
And we'll send all the presentations. I think in the presentations there will be links. Right?
Yes, absolutely.
Awesome.
We'll try and see if that works.
It will work.
Oh,
no worries. You told us that that's Murphy, like not found. That's good that we had this not found in the end, right?
Yeah, there we go. There we go.
Awesome.
So, awesome. All right.
Okay, I think that's a perfect place to end our awesome opening keynote. Let's give it up for Akmal.
Okay, thank you very much.